Hey guys, welcome back to another episode of Simulators. Let me just open up my blinds real quick, and we are good to go. Today, believe it or not, will be the very last day we're going to be working on our geometrical optics simulation. So here's the thing, we've done a lot of cool stuff with this simulation, and I'm very happy with how far we've gotten. We have one more thing to do, which I failed to do up to this point just because I've completely forgot to do it. But really there isn't that much left. We just have to do basically plotting of a function, which should take no time at all. I just want to do it in Cairo, and then we're done. So I think, I think this has turned out quite well. Hey Gustorn, so the idea, let's see, 6 months ago or whenever when we did this initially, we were moving on to a finite difference time domain simulation. So I wanted to see actually light, like the quantum nature of light, and show that quantum optics and geometrical optics give very similar results except for in very particular regimes. And I was going to make a video on that. However, the FTTD stuff didn't work out, so I kind of ditched the simulation and went on to something else. However, I think I just used however twice within a span of 10 seconds. Anyway, the I think it turned out pretty well. I think this particular simulation, we have some now visually appealing graphs, and it's pretty cool. Sine of parameter times r plus 1.0. I will add that to the queue. The first thing we need to do before trying new functions is I need to write another quick function just to draw out the appropriate index function with time. So for the index mod function, when the index is being modified, I want to be able to draw out the function in a pretty easy way so people can more easily see what's happening. But that's the last thing we need to do, and we'll spend the entire last hour implementing a whole bunch of different functions, just because, hey, why not? So, just in case people have not been here before, let me go ahead and open up Zernal, talk about what we're going to do today. So, throughout the past week, maybe, no, more than a week, 2 weeks, which is something I probably should talk about, we've been talking about geometrical optics, and honestly, we've just been working with this spherical lens. The idea is that we have light coming into the lens, and it does something on the inside of the lens. If we have a typical refractive index, it's just going to do something like this, and then pop out on the other side. Actually, it might be... yeah, I guess that might happen right there. Yeah, something like that would probably happen. Okay. However, we have atypical refractive indices that vary as a function of r. Here's r. So it could be 1 over r, such that the index of refraction here is much, much, much higher than the index of refraction here. This means that light will bend according to the new index of refraction. So we can see something happen like this, where light will come in, and it will just kind of spiral into the center. Or something like that. We have weird things happening to light inside of the lens. It's important to note that as light's going through a new medium, it's always going to, well, if the medium has a higher refractive index, it's going to slow down in speed, which is incredibly important for a number of different things. Now, what we're doing here is just kind of meddling with these functions a little bit, trying to figure out what works and what doesn't, and we're trying to basically just, I don't know, show how cool light can be in a way. So in this point, the point of the simulation isn't necessarily to learn anything at this point. It's basically to just, well, see what we can do. You know, it's a very interesting system with a whole bunch of interesting properties, and we're just trying a whole bunch of functions out and seeing where we can go. So that's kind of the idea there. The one thing I need to do before moving on to visualizing different simulations here is I want to be able to draw a single plot, something that looks like this here, where this is an index of refraction here, so IOR, and this is R, and here is R of 1. So this is R equals R. Let's put this as lower R, because that's defined as capital R. So in certain cases we have a weird function that's being drawn from 0, so R equals 0, the very center. And it might look something like this. In the end, it always ends at 1. So we always have the index of refraction here at 1. So what I want to do is just very quickly plot this so we have a plot of this potentially changing with time, and it won't take very long. I think it'll take like maybe 30 minutes or so. I'm fairly certain we can do this fairly quickly. And then we'll just spend the rest of the day implementing functions. So again, like Gustron has, if you have any interesting functions you want to implement, give them to me and I'll totally implement them as soon as I see them, or as soon as I can. Yeah, so we'll see what happens. Hopefully it'll turn out pretty cool. So I'll keep those in mind, and then we'll come back to them at the end of, well, when we start working on these. So we've got a whole bunch of different ideas to implement, and we'll see what we need to do. So pop that over there, pop that over there. Let's cd into the appropriate directory and get this done. So cd into projects, Simuleos, and of course, Geometrical Optics. Over here, cd projects, Simuleos, and Geometrical Optics. Let's go into the file, vi geometrical.cpp, and let's go ahead and, oops, sorry about that, geometrical.cpp, and let's do it. So we also need to go into geometrical.h here, .h. Okay, so now let's go ahead and add in the function we need. So here we have print index, and we're going to say function to draw, or rather plot, index function instead of lens and propagate. Okay, so this is a pretty simple function. Here's the idea. We read in the lens, which already has the function as a part of it now that we've done all the template stuff. That was a good call. And then we just plot it out. So we need void draw function, and we need frame animation, double index. Oh no, I think we just need sphere ampersand lens. Oh, I guess it's gonna have to be up here, isn't it? Okay, let's do, we have propagate sweep. Yeah, okay, so we're gonna have to do it this way. We'll do template T, and the template T will be for the type of object that we're working with. So it's gonna be constant T ampersand a lens. Okay, now what else do we need? At this point, I think that's all we need. Let's go down to propagate. Okay, propagate is there, here. So we have I begin, I end, we won't need that. Double step size, that's something we could use. Max value, double time. Okay, so what we'll do, we're gonna have to either draw this on all frames as the function changes with time, or we're going to have to change this, or we're just gonna have to draw it once. So what I think I'm gonna do is, I think I'm gonna say double step size. We're gonna need that. So let's do double step size. This step size in, oops, my bad. Double step size. Okay. But then we're gonna have another function down here. Function, did I do this right? Yeah, I think so. And this is gonna be a function to plot index for prop mod. Let me see. Nah, it should be okay. It should be okay. I think we'll just do the whole thing here and draw a function. Worst that happens is we draw the function over and over again for no apparent reason. This is primarily for propagate mod. E4 propagate mod. Okay, good. So we are getting there. Now let me go ahead and add it in over here. So add this guy in here. Type name. Thank you. Template type name. I did that wrong. Sorry. Good. Let's go over here. Template. That's not how you spell template. Type name T. Good. Okay. So now let's go here. Again, this should not take that long. Okay. So what we need to do then is we just need to plot out the appropriate values here. So what are we going to do? We have step size. We have the length in which we need to draw everything. We have the function we're working with. So we should just be able to go through all the appropriate draw frames and draw the graph on all the frames. So, and again, guys, this will be a separate visualization to what we're visualizing outside of this. The reason I want to do it this way is simply because this way we have two different visualizations, and I'm not sure the best way to put everything. So later on, when I do the video editing for our video for this particular simulation, I'll kind of figure out where I want to put the graph so people can see the index changing with time for the visualization of the propagate mod function. Okay, so visualizing the, let's see, changing the refractive index as it changes with time. Now, one thing that we could do is we could give propagate mod and draw function both a range in which they're going to work on. So that would be giving them a start and end. Yeah, I guess basically just a start and an end. Yeah. Oh, we have to be kind of careful with this, don't we? Okay, so one thing we did with propagate mod is we went through, let me see. This will be okay. We'll figure it out. Okay. Visualization of refractive index is a change with time. Let's do it. So we're going to say for int I equals 0. I less than, we need the total number of frames, so animation, oh wait, what is the total number of frames? Frame number. Okay, I less than frame number minus 50. Just to make sure I got this right, I'll check that in a second. I plus plus. I think it's plus plus I don't really care. Let's go here. There. Let's do frame number. There it is there. It must be num frame. Let's go to num frame. There. There. Okay, so let's go down to the bottom. This is going through all of the frames. Now, the trick is, we need to start visualizing or animating. Yes, that's what I intend to do. So we need to start animating the visualization at the frame. Let me see. At the frame. 0 to R is fine, but I want to go just a little bit above R. Well, maybe we don't have to. We'll see. Okay, so we need to start animating the visualization at frame. At the frame that corresponds. This is a super long comment. I could probably shorten it up. Drawing the circle and animating the lens index. Okay, so we're going to say animation.current frame plus equals, and I think it's 12. Okay. For now, we might have to modify that later. We'll see how it goes. In fact, why don't we just draw the indices in that time? Yeah, we'll just draw the indices in that time. That'll be great. Okay. No time at all spent there. Okay, so let me see how long I actually gave them. So let me go up to animate circle. Here we are. Let's see, propagate sweep takes that amount of time. That's fine, but that's not what I want. Propagate. I want propagate mod. Here it is. I give them a... I don't give them a double time. Where do I give them a double time? Propagate mod. I guess it would make sense for me not to, right? So, index parameter. Let me just go up to main. Okay, let's see what we have here. Propagate mod, draw layers, auto lens, make sphere. Light generation, draw lens. There it is, the draw lens command. So, let's go here, right and quit. VI, optics visualization .cpp, and let's go down to draw lens. Draw lens. Quit. up to visualization.h, draw lens. Here we are. Next, draw lens. Okay, this is when I give it a double time, and the double time is 1. Okay, so that's 1 second. Let's go down here, and it's going to be 1 times animation.frames per second. And again, the seconds will cancel out. We have a total number of frames there. So we start I at animation.currentFrames. Good. And then it goes through here. Now, one thing I want to do is in this time, I want to actually draw the axes, I think. That way we have something done. So let's just go ahead and say, we'll animate line from that time. So we'll say, this is actually going to be draw frames. Here. Like we said before, and here we're going to say double. Although I think it's always going to be an integer. And then we're going to do this. So let's say int draw frame. And I think I need an S at the end just to keep notation consistent with what I did before. Now we're going to say, that's the total number of draw frames. So now we're going to say animate line. Okay, and here's where things get a little bit weird. I have to kind of think about how I want to map the indices in our visualization to the actual plot that we're working on here. So let me think. I want one line to be not at 0, but at 1. And I want the other line to be at, I don't know, 0. So let me think. It's going to be index on the y-axis. It's going to be R on the x-axis. Then it's just a matter of animating the appropriate lines and going from there. Okay, so we're going to say animate line. I think that's what I called it. Animate line, that's right. So we need animation ray frame. The frame it's going to be drawing on. Time, temp p, ray position, and white. So let's go down here. Animate line. What are we going to do? We're going to say animation ray frame. So it's going to start at 0 time 0 time we want it to take, which is going to be 1 second. Then what else do we want? We should probably read in time. Okay, it's going to be time. Here we are, double time. Now we need a position to start from and draw to. Wait, why wouldn't I put the x-axis? Either I put the x-axis at 1, or I draw an additional line for the x-axis to be at 1. Because in the end, all of the indices end at 1. So, I don't know, it kind of makes sense for me. So, either that or we just draw a dotted line there, which I guess is also fine. Okay. So we do animation 0, time. And then we have to have a starting and ending position. And I think, yeah, we also need a color. So let's go ahead and define the color. Of the axes during that time. Because the index of refraction on the outside of the sphere is always 1. So it goes from an index of refraction of 1 to whatever it is inside the lens, and then 1 again, right? So you don't normalize them? No, it's the index of refraction of air is 1. So no matter what, if we're inside the lens, the index of refraction will be modified by some bit, but on the outside, it'll be 1. So, okay, animating the drawing of the axis during that time. Crap. 1 second. Okay, should be good. Okay, animate line, time. We need now a starting and ending position. So let's go here. Let's say color, white. It's going to be equal to, let me check how I did white before. There. Yep, 1110.5. So we're going to do, 1 second. 1, 1, 1. And in this case, I think I'm just going to do 1. Yeah, but I have to show that it ends at 1. So, I mean, that's the most important thing, right? Or one of the most important things, that the index of refraction goes back to what you would expect it to be. So, I really think we need an extra line there, because otherwise it's going to be very, very weird if it just all of a sudden stops. I don't know. I think I definitely want to show that. Okay. So, now let me think. What's next? Okay, so what's next is that we do this. So we say animation 0 time. Now we give it a starting and ending position. So we'll say, let's draw the line. We can give it somewhat arbitrary axes here, right? So we never do a negative refractive index. So we don't really have to worry about that one. Yeah, we don't really have to worry about that one. So we never do a negative refractive index. So let's go down here real quick. It's going to be equal to, plus equals draw frames. Okay. Okay, what else do we need to do? Actually, shoot, this might take longer than I want. We might have to do the epilogue tomorrow. Anyway, this shouldn't take so long. I thought it was going to take like 30 minutes, and it's already been 30 minutes, and I'm failing miserably, but let's do it. So color white. Now we need a starting and ending position. So defining starting and ending position of x-axis R. Okay, so we'll say, where do we want to start it? We could draw it just along the entire span, you know. So we'll say start P is going to be equal to, let's go here, call it a vector. Start P is going to be equal to, we can call it anything we want. So let me see. Vector of, let's say, yeah, let's have it start at 0 for now, and then it's going to be at the very bottom. So we'll say animation dot resolution Y, and let's say minus 50 or something. Okay. Now we're going to do NP. It's going to be equal to vector of animation dot resolution X, and then animation resolution Y minus 50. Okay, so now we have the starting and end position. So we're going to say start P and end P, and then we're going to say white, which is the color we'll be drawing it to. Now we have to do the same for the other one. So defining starting and ending positions of y-axis, which will be for the index. Okay, it'll be very similar. We're going to say vector. I'm assuming I'm doing these vectors right. Let me see. Where else do we define vectors? Vector normal at. 1 second. I might be defining these vectors wrong, so let me look. Vec. Here. There. Refract. That's fine. Nope. No, I got it right. Good. Let's go down here. Okay. So we're going to say vec start P. And we're just going to, actually, we're just going to redefine the same variables. No reason to change them. Start P is going to be equal to vector of, and in this case, we want to start it at animation dot resolution Y and 0 plus 50, so 50 along X. Yep, that should be fine. And then we do start NP, which is going to be equal to vector of animation dot resolution Y. Oh, just a 0. Sorry about that. 0. And then we're going to say 50. There we go. Okay, so now we're going to say animate line of animation 0 What's the 0 for again? Oh, rayframe. Then we do animate line. Where are we? Time, start P, and of course end P. White. One second, let me see. Animation at resolution Y. 50. What's wrong with it? I think it should be right. Plus equals draw frames down here. I think it's fine. So we're starting at resolution Y, which is the very bottom of the screen, and then we're drawing upwards. So I think that should be okay. But if I did something wrong with notation, let me know. Okay, so now we have to draw dotted lines at the appropriate spots. So let's do this. Drawing. One second. Oh, shoot, you're right. I had it backwards. 50, 0, 50. Yep, my bad. I don't know what I was thinking there. So now we have to do defining, starting, and ending positions for... It'll be okay. Okay, so let's go down here, and now let's just go ahead and start drawing everything else. So, right now I'm just going to draw it from 0 to R. We could draw excess. I haven't decided exactly how I want to do this, so let me just draw from 0 to R. Worst case scenario, we have to draw more. Best case scenario, we're set. Okay, so now let me think. We have animation current frame, we have the lens equation and everything that we're going to be working with, and we have R. So we basically have to map what is left in the pixel, like the number of pixels left, with the function we're working on with. So let me turn everything on, guys. Okay, so let me go up here and let's define the number of pixels in our range. So we're gonna say double, maybe int. Good. So now defining pixels left to work with in X and Y after, let's say drawing, axes are drawn. There we go. Look at my awesome commenting skills, guys. So we're gonna say integer. What I'm gonna say, let's say pixels, X pixels. Oops, that wasn't right. And it's going to be equal to animation dot resolution X minus, and I would say 50, but I think it should be 50 times 2. So let me think, what do we want to do here? Animation minus 50, start P, end P. So these are all the starting and ending points. So here's what I'm going to do. I'm going to go up here and I'm going to define a general offset of 50. So we're going to say integer offset equals 50. And let's go down here and change all these 50s to offset. So it's a variable that we can... why not plot it along the single middle ray? One second. Offset. What do you mean exactly? Sorry about that. Offset. So... and offset. That way you can match the function with the visualization. Why not plot it along the single middle ray? Oh, so like we have the visualization here and you put the plot right there. We could do that. However, no matter what, is the ray going through the middle? Yeah. I think I see what you're saying. So you just want, we have all the light coming in, and we put the animation like right at the middle ray or something like that. That's fine. I kind of right now want to just get the thing drawn. You know what I'm saying? Like, yeah, sure, we can see them both at the same time, But I can also just create a video later of them both at the same time with the magic of video editing, to make it look as good as I can, well, kind of figure it out to be. Which is not to say that plotting them together won't look good. In fact, it'll more easily create what we need. But I don't know. I don't know. Okay, so we have offset here. Draw frames. Pixels is going to be animation resolution X minus 2 times offset. Here we are there. And we're going to say int pixels, sorry, y pixels is going to be equal to animation dot resolution y minus 2 times offset. Okay, so this will create our you know, how much space we have left to work with. Now, we have this. I'm going to have to put down characters later. So after animating lines, let me go ahead and say that. Defining, or rather, placing R on x-axis, and I guess index on y-axis. Let me change this to a dash, and this to a dash. Good. Okay, so we have animation, current frame, draw frames. Good. So what else do we need? We have all the pixels we're going to work with. Now it's just a matter of, on every single frame, drawing the appropriate graph. Okay, so let's think. What do we need to do then? We've done this before many times with all the different animations and stuff that we've done. So let me think. We're going from animation current frame, and then we just go to each draw frame and we draw the appropriate graph. So let's say, so we need to go through all the positions of R that we're working with. We have step size, but you know, I'm thinking about it, maybe we don't need step size. Maybe we just go through each individual pixel that's left in the X pixels, and then we just find its corresponding R value and plot that. Yeah, I think that's fine. So the best way to do this then, let me think. We could also put X ticks on the Y-axis. It's fine. It's fine for now. We'll see what this looks like. If it doesn't look good, that's fine. We'll just move on. So this is what we're going to do. For int I equals 0, I less than, what do we want? Pixels, X pixels. Then we're going to do plus plus I. Good. So we're going to go through all the X pixels, and then we're just going to say the following. Let's say R. So it's going to be equal to, and what do we want R equal to? Why not plot it in the range X, Y, where Y equals 0 is a theoretical ray going through the center of the lens. One second, let me think about that. Let me go up here. Double R. So what you're saying, why not plot it in the range X, Y, where Y equals 0, and X is a theoretical ray going through the center of the lens. So what you're saying then is, let me think, why not plot it in the range X, Y, where Y equals 0 and X is a theoretical ray going through the center of the lens. Sorry, I apologize for that one. So double R up here, let me add a semicolon. And let's go down here and let's say, hey iCare, what's up? Oops, that wasn't what I meant to do. Thanks iCare. Okay, so we're gonna say R is gonna be equal to whatever we're on, so we're gonna say double of I divided by, I guess, number of X pixels. This should give us a number between 0 and 1, which is exactly what we want for our index of refraction. So now that we have r, we also have the index function that we're going to be working with, which we worked with before. So now we just have to kind of figure out the index at every single point. And luckily we have exactly that. So we have the lens, and let's just go ahead and call the index. So we're going to say index. Up here, let's define it. Index, let's say, is going to be equal to, and it should be just refractive index at. I'm pretty sure we can just do that. So let's look over here at refractive index at. IOR is equal to that. That's fine. Refractive index at. Oh, do I not have it in here? Right quit? I don't. It's in geometrical.h. Let's look for refractive index at, and let's see, vector p constant contains p. So we need to read in a vector p if contains p. Oh, we give it a position. That's not quite right. So let's see, for what are we doing here with the constant index? We need to read in, let me think here, double operator, constant sphere, constant index, lens, vector. Okay, so double operator, constant sphere, constant lens, vector. What are we actually reading in to this guy? We read in double R, double operator, inverse error function. So if it's within P, yeah. So I think I see what you're doing now. Why not plot it with a range x, y, where y equals 0 and x is a theoretical ray? Okay, I think I'm seeing where you're going. Yeah, I see where you're going. So we have R right here, and that's fine. What we'll do is then we'll construct exactly like what you said. So let me go here and let's call it vector. And we'll just call it ray. Ray position. Why not? And we're going to say ray position up here. So ray position is going to be equal to vector of, we're going to assume it is at y equals, yeah, exactly that. Yeah, that's this will do. if I can speak. Okay. So we will start with r equals 0. And here's what we're going to say. Y, oh, we're at x first. So x is going to be equal to lens.origin.x, I believe. Unless I'm doing the notation incorrectly, but I think that's fine. Lens origin x, and then we're going to say plus r. So it's kind of moving out that way. And then we'll say lens.origin.y for y. Good. So we have plus r. But actually, this is going to be plus I. Right? Yeah, that should be plus I. dd here. Remove this r here. Then we're going to say index is going to be equal to lens dot refractive index at, and we're going to run with ray p. Okay. Now this should be okay because, yeah, this should be fine. So we're basically creating a theoretical position of where the ray is inside of the lens. Okay, so now what are we doing next? We have the index here, we have the ray position there. So I guess now we just have to plot the index. So we will say double index, and what do we want? Double index before, I suppose. Or we just do draw line 2. Let's do this. Index previous. Maybe it should be previous index. Not sure. Sorry about my notation, guys. So index is equal to this. Now we just do chi remove 2. And we want to do, yeah, let's go up here and let's say, 1 second. Here's what I'm going to do. I'm actually going to change the word draw frames to draw frame singular. And this is kind of, it's fine. So now we're going to do kite remove to, and we're going to do animation dot current frame of draw frame. Okay. So this is going to be where we're at this particular point in time. And then we're going to say kite remove to the X and Y positions of, well, where we need to go. So this is going to be, I guess we should define an X and Y position, shouldn't we? Okay, let's do that. And then we need X and Y. Okay, so where's the X position going to be? We're going to say X is going to be equal to, I think what I just said before, it should be I, let's say double of I, divided by yeah, basically I, but it needs to be I divided by X pixels, because this should give us, oh no, you're right, it is just I, it is totally just I don't know why I keep thinking about that. So it should be X pixels. Oh no, I, gosh darn it, I, and then index. Index, we're going to have to multiply index by an arbitrary factor, because index is going to be like, I don't know, some sort of, I'm just going to multiply by an arbitrary factor and let's see what happens. So let's assume that index is about 1. And we have, let's see, how many frames to draw with? We have, 1 second, I'm thinking. We have X pixels, or Y pixels to work with. So let's just go here and let's say Y is going to be equal to index times Y pixels. Okay, index times Y pixels times 0.5, so why not? I minus 1 in the previous index. Yeah. Oh, yeah, wait. I have to think here. Okay, index Y pixels 0.5. Then what we'll do is animation dot resolution Y minus offset minus that. Good. Okay. And we'll call this previous index. Okay, so let's go here and let's say Y. And I think that'll do it. We'll see what happens when we draw it. If it draws incorrectly, which means we'll need to check if I equals 0 and only move to I. Let me think. If I equals 0, yeah, so let's do this then. If I equals 0, else okay. Okay, so where are we going to move here? Okay, so we're going to kind of move to. Where do I want to move to? If I equals 0. Wait, why do we have to do I minus 1? 1 second, let me think. Why is it I minus 1? Oh, because we're moving to the previous frame. Yep, you're totally right. So how about we just start... 1 second. So I is going to be moving along all the pixels. That's fine. And so we're going to be at some sort of... You define Y as Y previous. Yeah. 1 second. I have to think about this. Give me some time. In the meantime, or while we're thinking about this, of course, if you guys have any questions, comments, concerns, let me know, and we will totally talk about those as soon as we see them in chat. Okay, so if y equals animation resolution y. Okay, yeah, so I think here you're right. We're just gonna do Chi remove 2. And it will be animation dot current frame of draw frame. Then we'll say, why is this longer? Oh no, it's not longer. So we'll move to 0. Shoot. 1 second. X pixels. I should start at offset, I think. One second. Lens origin X. I have to think about this. Sorry about that. Okay. Let's keep this starting at 0 so we don't get ourselves confused. And then we're gonna say this is gonna be at offset. And the current y. Okay. Let's go down here. I minus 1. No, wait. Plus offset. Actually, I don't think we need to have a special case for I minus 1 or I equals 0. 1 second, let me think. Yeah, and then we have to move this to y previous. You're totally right. So we'll say, wait, let me think. So we move to the current position that we're at. Oh, how about we just move to the current position? And then draw a line to the new position. Let's do it a different way. This might make a little bit more sense. So no matter what, we always do a Chi move to here. Yeah, I'm working on that. I've got a little bit to think about here. So let me just do this. So we don't do I minus 1. Instead, let's do this. So let's say if I equals 0, we don't draw a line. Otherwise, we say, then what do I want to say? We are going to draw 2. We already moved 2. So let me go down here and let's do Chi line 2. And let's do animation.current frame of draw frame. Oh, that was not the underscore I wanted. Okay, and then we're going to say Chi line 2 I plus offset Y. Okay, so we don't have to keep track of any previous anything really crazy here, right? So we draw a line to it. So first time step, we move to the spatial step. So we move to the current location. Next time step, we draw. Next. This should be okay. I think this will work okay. So that means we don't need previous index. Okay. Then at this point, we're going to say draw frame plus plus. Okay? Yeah. Something like this. Okay, let me just go up to and add in the draw function command. So let me go up to main. And instead of doing propagate mod or any of that kind of stuff, let's just draw the function. So let's do, and this should draw the same function everywhere. So let's do draw function. 1 second. And let's just make sure we have everything set. So let's go down to the bottom and we're going to say, you know, we didn't use step size. But we did do something else at the end there. What did we do at the end there? We added in double time. So let's do frame animation. So we're going to animation lens. And then we want time, which we're going to set to be 1. Let's go down to the bottom here. And actually, we might finish within the hour if we're lucky. Which we're never really lucky, but let's pretend we're lucky for right now. Good. Double time, write this, go over here, right and quit, and let's make it and see how it breaks. Good, so 65. Says draw function, animate lens 1, anim was not declared in the scope. Oh, that's because I need to give it a layer to draw on. Of 1. And now let's make that. Okay, so num frame was not declared in the scope. That's because it's num frame, so 414 with an S. Int, let me see. Invalid types int for array subscript. Invalid types. I'm not quite sure what that means. So let's go here, write that, go over here, make, see if it gets rid of, no. So these are still here. So animation current frame, draw frame. I'm pretty sure that's how we normally do it, but let me check. So we have that. Animation current frame, draw frame. Oh, did I give draw frame a double? No, draw frame is an int. 1 second. Invalid types, int for array subscript. 1 second. Let's go down to frame context. Oh, what did I call it? Animation current. Oh, that's why it's frame context. My bad, guys. I was just, for some reason, not thinking. We need to obviously grab a context here. Yeah, you're right, you're right. I was not thinking when I was writing this. Now let's make that. Okay, so it seems to make. Now let's take a look at the final plot. Again, it should just be plotting a single thing. So let's go into the last mirage should work. Okay. We still drew the lens, which is unfortunate. We have the lines being drawn on the side here, but we're not drawing the function. Okay. So let's go through and let's not draw the lens in this particular case. So let's go up to main. Here we are. What happened there? Did I accidentally put in a tab? Huh. Okay, so where do we draw the lens? Radius. Why is everything tabbed? What? Absolutely everything is now tabbed. Why? How did everything get tabbed? Everything is tabbed. Okay. Well, that's a bit of a pain. Okay, we're gonna quit. Vim geometrical.cpp. Let's see what lines these are on. So set number. It is on apparently 24 too. Let's remove that one. Okay, so 27 to 373. So we're gonna go. Let's see, what is it gonna be? It's gonna be 27, 373. 373. I have no idea how it got tabbed. S, and then we're going to say we're going to replace the what is it going to be? Something like this? Yeah, that was it. Okay, so let me go here and let me just make sure. So let's do set no number. Okay, so I think that fixed it. Again, I have no idea what happened. But that's okay. It seems fixed now. Oh, it's okay. I got it. We are set here. Okay. So, we're gonna quit. Back to VI. Okay. Now, what are we gonna do? What I need to do. Oh, I need to not draw the lens. So let's go down to main. Don't know what happened. Lens, let me draw lens. So let's not draw the lens in this case. Okay, now let's go down to draw function and let's see what's up. So apparently we're not drawing on any of these frames. Caroline too. Oh, you know what we're not doing? I forgot to stroke it. Current frame, draw frame. Okay, good. That is done. Write that, go over here, and let's make that. Okay, so now we should see everything being drawn. And that should be okay. I feel like there's only Gustorin and I care here today. Where is everyone? So let's go to Mirage Temp, scroll down. Okay, so that's something. Is that what we expect to see? I don't know. So let's change the let's change everything to something that we do know what it's supposed to look like. So let's go to what do I want to do here? Draw function, draw lens. We have so many things. Let's not do sigmoid index. Let's instead do inverse index. Write this, go over here, and let's make that. Okay, now let's take a look at Mirage Temp. Okay, well that's almost right. But it's not quite. It should go down further, I think. It should just be 1 over r, right? So we should be seeing this taper down. Let me think. So let's go down to the draw function. Here. Where's draw function? Oh, we're in draw function. So ray P, vector, lens origin X. Let me see. Ray P, lens origin X plus I. Oh, that's probably why. So the index is 1 here. Okay, so what we need to do then is something a little bit weird. Yep. So let's do the following then. We want to map every pixel along the X direction as R, right? Yeah, that's what I want to do. Either that. Let me think. We could do a number of things here. One of the easiest things is just to say ray position is going to be this, but it's actually going to be double divided times 0.5. Write that, go over here, quit, and let's make that. How did I spelled it right and then I spelled it wrong? I think. I don't know what I did. I'll give it a second to draw. Honestly, I would. So it starts with 1 and ends with 1. Yeah, we could do it that way too. So we have draw frames. Okay, so let's do that then. We can do that just fine. So we're gonna say lens origin X. Hey, Duck of Doom 12, how are you? So let me think here. What do we want to do then? What we could do instead is just this. Let's just do offset plus I. Let's make that. Give it a second. Okay, so now let's take a look at Mirage Temp. Yeah, that's what it would look like, right? And what we could very easily do, Vim, no fancy theme, no fancy set number, nope. Thanks for coming in, man. That's this stream. We kind of do things super simply here. Okay, so what do we do next? Y animation. Let's change this so it's times 0.25 or something like that. Just arbitrary offsets for now. We can fix it a little bit later. Okay, let's take a look here. Mirage Temp, scroll down, and that's exactly what it's supposed to be, right? It's 1 over R, so it goes way up, way back down, ends at 1 over here. Okay, let me try something else. Let's go up here to 1, and let's go to change this to the inverse error function, index. And let's make that. I set line numbers on when I'm doing debugging, but usually I don't need them. So let's do Mirage Temp, scroll down. Okay, that's about what you expect for what we have for the current function. For the inverse error function. I don't know if I like this one or if I liked it starting at 0 better. We'll see. Okay, so now we have to do one more thing, which is going down here. Okay, so what we need to do is every one of these frames, we need to change one thing, which is going to be the index parameter. Now let me think, what did we do before with the index parameter for propagate mod? Here we go, propagate mod, and let's see what we do with the index parameter here. So it should be cover line 2, where is the index parameter? A refractive index at, I know we update the index parameter in propagate mod. So lens refractive index at ray p index equals lens refractive index at ray p. Why? Oh, I am not in propagate mod, am I? Now I'm in propagate mod, and we say propagate animation current frame. It doesn't have to be symmetrical, left, right. Yeah, okay, sure, fair enough. So let me think. Yeah, fair enough, so I could put it directly under. Okay, so lens index parameter plus equals, that's what I want right here. This is exactly what I want. Bam. Okay, let's go down to the bottom. And what do I say, num frames minus 50. Yeah, should be okay. So we have this, let's put it here. Lens index parameter plus equals index max minus start index. Number of frames minus 50 start frame. Okay, so let me think. What is index max? What is start frame? Oh, these are things that these are parameters that we gave them. So what we could do then is go up here and add those values to our draw function. Let's do that. So we'll say double index max and start index. So double start index. Okay, so we'll be reading these in. Let me go over here, vi geometrical .h, go down to the bottom and add those in here. So we'll say double index max, and of course, double start indexed. Good, brain quit. So that's done. Everything else is okay. So let's see what happens if we write this, go over here and we make it. Start frame, not declared in the scope. Start frame. Let me see. Wait, why would... I thought the line numbers were just to... it's fine. Okay, so where do I want to go? See here, start frame was not declared in the scope, obviously, because I forgot to declare it. Let me go up to see what we defined start frame as before in propagate mod. So here's propagate mod. We do propagate raise. Let me see. Start frame. Start frame is defined as animation.currentFrame. Let's go down to the bottom here. Do we have to define that? Probably. So let's do this. Let's see what happens here. So animation current frame, instead of start frame, let's just add an animation current frame. Because we don't... Yeah, animation current frame. Let's see what happens. What's the worst that could happen? Make it... well, it breaks. That's one thing that could happen. Draw function. Obviously, we were calling that incorrectly, so let me go up to main. And let's do draw function, which is right here. It's going to be the same at the end as propagate mod. So let's see, layer 1, 2.0. Wait, let me check propagate mod real quick. We're reading in double index max. Oh. Wait, what? Oh, my bad. Guys, I apologize. Let me just put in index max. We don't need the start index, because the start index is going to be exactly what you would expect it to be, the index that we define. What? I'm super confused. Did we just tab everything again? What happened? What the heck? How did that happen twice? Okay, there's some sort of keybind that I'm not paying attention to. Okay, draw function here, and we're going to change this to a 2. Good. So let's go down here, and let's remove animation current frame, still there. And let's remove this bottom line right here. Double start index not necessary, just double max here. Let's go over here. Geometrical.h, dd that, remove here. there. I would have, yeah, maybe it is. Maybe I just pressed Q. Maybe somehow I just did some weird key combination that I wasn't paying attention to. Okay, so let's see. Cover stroke, cover line 2. What I want to do, index parameter, index max, start index. So we're going to go up here and defining starting index for index sweep. I guess that doesn't need a space. So we say start index is equal to be lens.index parameter. Good. So now let's go down here and let's change that. Oh, start index is fine, index max is fine, animation current frame fine, right quit, make. Oh, what happened here? Animation not declared in the scope, 385. Draw frame. What? I'm reading in animation. Anim, not declared in the scope. What is your problem? It says animation is not declared in any of these scopes, and I'm not sure why. Start P does not name a type. Oh. Ha. My bad. Now let's make it. Lens.index parameter. Of course, it's index param. My bad. I keep making typos today, guys. But I keep making typos every day. That's how it goes. Write this. Now, start index was not declared in the scope. Of course it wasn't, because this needs to be a double. Make. Index parameter. Assignment of member sphere inverse is read only. Yes, because I set it as a constant. Lots of bugs. Sorry about that, guys. Let's go here. Change this just to T lens. Let me go into geometrical.h over here. Down to the bottom, change this again to just T lens. Right, quit. Now let's try making it. Oh my gosh. What's the issue here? In main, double, error axis status, void draw function, sphere inverse error function, frame, sphere inverse error function, double. Okay. 1 second. What is your issue? Let me go into geometrical.h real quick, and let me see something. Theory of struct sphere. Let me just go down to propagate mod. I'm doing something weird. Template type name here, T-lens. What is your issue? Draw function, frame animation, double time, double index max. That is exactly what I have up there, so I'm not too worried about that one. Frame animation, draw function. Okay, so let's take a look at that error one more time. It says geometrical CPP 65. It says undefined reference. So let's see, layer 1 should be fine, lens should be fine, draw function, sphere inverse index ampersand double. We have 2 doubles, should be okay. Frame should be fine. It's probably screwing up with the sphere inverse error function index. So, how do we fix this problem? Not sure. So let's think. Draw function, layer, lens, 1, 2. Let's go into geometrical.h, but on this screen over here. Geometrical dot, where are we? VI geometrical.h. Go down to the bottom, and let's see what we got here. Draw function, template type name T, draw function. The constant lens will give us a problem because we try to modify it. But it will work. So let's go here. Quit. VI geometrical.cpp. Go down here. And if we comment these guys out, it should work. So let's go up here to constant. Make. Yeah, so that one works just fine. But the constant index. Oh, okay, my bad. Let's go up here. go up to main, scroll down here and change the inverse error function to just constant index. Now let's go into right quit, vi geometrical.h. Scroll down to the very bottom, and then we want to change this to a standard T lens. Right quit, vi geometrical.cbp. Let's go down here and let's comment these guys back in, and then write it and make it. Make. Oh, actually, that one works. What? Let's take a look at this. So we're gonna do. Oh, that's not what I wanted. We will do the last mirage, wherever that is. Can't find it, so let me just do mirage. Good. We scroll down. There we go. Look at that. The index is changing. Good. So this would be our animation of the index changing with time. That's fine. Okay. Why would the inverse error function not work? So we need to get that inverse error function one working. I'm gonna give this the same error as before, or maybe not. Huh. Okay, that one worked. Not sure why. So let's go into Mirage Temp, scroll down. Yeah. Okay. So we can do some things here to make it a little bit more visible what's happening. However, this is what I wanted to see, right? So, let me show you guys what it is that's actually happening here. So this index of refraction here, again, we can multiply it by arbitrary numbers to make it more visible what's happening. But what this corresponds to is the image that's happening. Oh, actually, you guys might not see it yet. So let's go here. And let's show what this is. So let's go here and here. Okay, so remember that plot that we just made, where the index. Here, let's just make this. Why not? Make it. Pass in scale y. Oh yeah, that's probably the best way to do it. So let's do propagate sweep function. We will add in a scale y, which I'm going to put as 5. Arbitrary. And let's go up here and add in a double scale y. Down here. Double scale y. And let's go down here and fix it up. So what do we have here? We have start index. Where am I going? Y is animation resolution. Y pixels times 0.25. So this is going to be 1 over scale y. Oh, wait, let me think. It should be 1 over scale y. Okay, like if we remove this guy completely, then that means an index of 1 is going to be at the very, very top. Why not? We can multiply it by scale y. That makes sense. Okay, so now let's take a look at this animation here. So we do Mirage. Okay, so the animation we just made was actually of the same thing we just saw. Ooh. I forgot to draw the lens. Let me go to the top. Let's draw the lens real quick. Draw lens. Write this, go over here, make it. Okay, while this is making, let's go into geometrical.h. Geometrical.h. Let's go down here and let's add in a double y. Scale y. And quit. Geometrical.cbp. Yeah, so what I'm doing here is, let me see. Animation y. Yeah, I'm doing exactly that. I'm just making sure it stays within the graph. And animation resolution y. The number of pixels that we're working with. Minus offset, minus, yeah. So this should keep it within the graph. Good. Let's write this. Now let me go up to main. Main. Let's go down here and change that to a 1. Oh, let's change it to a 0.8. Actually, before the offset. 1 second, let me see. What do we have here? Index parameter is equal to index max minus start index. Oh, that's not what I'm looking at. Y equals animation resolution Y. So that's putting it at the very bottom of the screen. Minus offset, that's putting it to where... Yeah, no, I think this is right. I totally think this is right. Let me go up to main. And let's change this value that I was going to change before from a 5 to a 0.8. Okay. Okay. Let's do Mirage. Let's scroll over here. Okay, so that plot that you just saw is actually the plot of this visualization. So we start with an index that's basically 0. And so all of the rays are initially reflected off because of total internal reflection. We scroll down, and then we have the rays come in. Here, first rays come in. Second rays come in, third, fourth, fifth, sixth, seventh, eighth, and finally ninth. And then at the end, it ends up being a refractive index of basically 1. The index of refraction is the same on the inside and outside. So I want to plot this. Let's go into propagate. What am I doing with my life? Here. Where am I? Auto lens, make sphere, ray array, draw lens. That's what I don't want. Okay. Now we want draw function in. Let's write this, go here and make that. Give it a second to do it, and I think this should work just fine. Hopefully. Okay, so now we're going to do the last mirage here. Scroll down. Here's that. Okay. It can still be work touched a little bit, but here's basically what's happening, right? We have the index. Yeah, so the index starts off something like this, so it's a lower index, and we have some sort of plateau in the center, and the plateau slowly gets larger and larger and larger until we're at an index of exactly 2, or the index parameter is exactly 2, in which case we have basically 1. So let's go here. 1 second, where is it? It was there just a second ago. Oh, there it is. Basically 1, right here. Now there's one thing that I failed to do, which I need to do. So let's go here to the propagate mod function. Okay. You'll note that in the propagate mod function I had an additional, how do I put this? An additional loop to set the final image for the rest of the animation. We can do the same thing here. So we do draw frames plus plus, and then we do, let's go up here, setting the final image for the rest of the animation. Okay, so let me go up and check the indices that I had before in the propagate mod function. There it is here. Animation current frame num frames I++. Quite frankly, I'm just gonna grab this. Feel free to judge me. DD. Animation current frame num frames propagate. We don't need to do propagate in this case. Print index. There. Okay. There. Okay. And I don't care about the current frame here. All I want to do is this. So we're going to have to do for int I, let me think. Lens index parameter. Oh, okay. So we're actually going to have to do, let's just do this a little bit differently then. Okay. So let's go up here, num frames minus 50. Let's remove the minus 50. And let's say, if I less than num frames minus 50. Oh, my bad. And then we go here. And let's make that. And this should keep the image at the end. So before you saw that it just randomly disappeared, this one it should not randomly disappear. So let's do Mirage. There's our drawing of the plots. And it shouldn't disappear. Oh, it does disappear. Why does it? Oh, but it disappears at 291? It's a weird place to disappear. Not sure why. But it does stay constant for a while. Why 291? 9 frames before the end. Weird. Okay, let me think. If num frames, if I is less than num frames, index parameter. Otherwise, the index parameter should remain the same. less than num frames, animation current frame, num frames. Let me see, plus plus I. We're totally going through all the frames. Let's just do something real quick. So let's do stdc out I. 1 second, I, and then end line. Make. Goes through all the frames. Oh. One second. I didn't make this mistake, guys. Someone else made it in my place. That was stupid. I'm sorry. Let's go here. RJ. Next, RJ. Now let's make that. Make that. Yeah, the internal loop had the same index as the external loop. So now let's go to Mirage Temp. Scroll down. Oh, what the heck? That's not what it should be plotting at all. What the heck? Why is this broken now? Everything's broken about it now. Ray P is still wrong? Let me see. Where's Ray P? Vector. Oh. Thanks. Now let's go over here. Make it one more time. We still have that one problem that it doesn't complete the animation. And I'm not sure why. So let's do Mirage. Scroll down. Okay, that's what we want to see. Everything's fine. But watch, 290. I bet you 290. It's gonna. Yep. 290. It stops 10 frames before the end. Why would it stop 10 frames before the end? Okay. 4J index. We just went through all the eyes. It totally went through all the eyes. Let me go here and let me do. Draw frame plus plus. We should be going up with draw frame every time. Let's just output draw frame too. So let's go here. Let's do stdc out. And we're going to do draw frame. Okay, end line. Make that 290. That's why. So draw frame doesn't go all the way up. So it must start at 0. No, it starts at 11. What? Every time we increase I, we're also increasing draw frame. So why on earth would draw frame end at 90? Animation current frame, which should be equal to draw frame. In fact, we don't really even need draw frame. We could just use I. I. Okay, and then let's see what happens here. Good. Oops. Make. My bad. Oh, that one seemed to go quite quickly. Now I'm a little bit worried. Now it seems to work. And it's there all the way. Booyah. Done. Okay. Don't worry about this draw frame nonsense. Done. Everything, this is done. We've officially plotted our guy. Oops. Okay. So, I'm happy with that. That's all I wanted to do. Let's go up to main. Now, for the rest of the day, I realize we only have 30 minutes left. For the rest of the day, let's get some functions in here. So let's see. Auto lens make sphere. Draw lens. XX. Right, this. Gus Run suggested some a little bit earlier, so we'll take a look at those. Let's go into VI geometrical .h. And what was one that was suggested? Let's go over here to chat. Let me scroll up a little bit. Okay, so let's see. Sine of parameter times r plus 1. Or sine of 1 over parameter. Let's go and create that lens. So let's go down to all the lenses that we have over here. Where are we? Invisible index. R index. Now we can say struct. For, let's see, what are we going to call that? Sine. Inverse. R. Index equals to sine of 1 divided by parameter times r plus 1.0. Okay, I think that's right. Page down. Sorry about that, gust join. It took me a lot longer than I thought it would. But everything takes me a lot longer than I think it should. So I don't know why. I'm sorry. Struct of sine inverse r index. Okay. It's kind of a long name, but it's okay. It's kind of a long thing. So double operator here. Then we're going to say constant sphere of sine inverse r index. Yep, that's right. Ampersand lens. Then we're going to do vector p. Okay, then we're going to say constant. Just barely fits in, but that's okay. And big O. Return. Lens dot index parameter. Okay, so what do we want here? We are going to want to do return this. Where are we? Sine of 1 over parameter times r. Okay, so let's go ahead and define r for this one. So we'll say r double r is going to be equal to the distance. Thank you. And this is going to be the distance between, what do we want here? We want lens.origin, and of course, p, the position vector that we're working with. Now we're going to return the function that we're working with, which is sine of 1 divided by parameter, which is going to be the index parameter. So let me see, lens.index parameter. Okay, times r. And then it should be plus 1. Is that within the parentheses? Or outside the parentheses? I think it's outside of the parentheses. 0.0. 0.0. And a semicolon there. Okay. So I think if we just go over here to inverse error function index here and change this to sine of inverse. And sorry for all the comments, guys. Sine inverse r index. Go over here, write this, make it, see what happens. I of course forgot something. So it says 178, geometrical 8, 178. And what did I forget? Semicolon there. Thanks, my apologies. Now let's make it. Okay, let's see what happens. Max index is 2, that's quite good. That means it's actually a reasonable function to work with, which I guess because it's bounded by sine, that's fair enough. Okay, let's take a look at it. Mirage here. Scroll down. Whoa! Does that make sense? Okay, I forgot to do one thing, which is I'm currently, see, propagate mod, not doing any propagation. So let's just do standard propagate for now. Oh, or we could do propagate mod. Let's do propagate mod. This one looks like it might be interesting. So let's do make. Give it a second to do its thing. It's going to obviously go through all the indices and stuff like that. We're multiplying by index parameter. So we'll see what happens. The index parameter is varying from 0 to 2. So because the index parameter is within the sine, I have no idea what this is going to do. We'll see. Now let's take a look at it. Let's do Mirage image, PNG. Scroll down. Here's our guy here. Oh, it looks like they're all just reflected off. Why would they all be reflected off? It could be. The max index was 2, wasn't it? Let's just do propagate. Make. Oh, I know why they're all reflected off. Yeah, that totally makes sense. Okay. We need to do +2. Mirage temp. Yeah, so these will all be reflected off too. Yep, okay. Let's try +2 instead of +1. via geometrical.h. And now let's go to inverse, I'm sorry, sine inverse. And let's change this to a +2. Now let's make that. The max index should be 3 in this case. I think sine goes from 1 to -1, right? So if we just add 1, we still have an index of 0 at some points. So let's try this. So let's do mirage temp. Scroll down. Does this basically the same thing? Yeah, okay. I want to see these squiggles. Okay, so what's super cool about this one, and I don't know if you can see it on your screen, but actually these guys are squiggling by a good bit. So here's what I want to try. I want to go to, where are we? Geometrical.h. Let's go down to inverse, sine of inverse. Here we are. And let's see, lens index parameter. Let's multiply this by an arbitrary factor. Let's say 5. Now let's make that. Okay, what this should do, if I'm not mistaken, is it should increase the, how do I put this? The, oh, I did it the wrong way. Oops. I want to do 1 over that then. Let's go to geometrical.h, sine inverse. And let's just change this to then 0.2. And let's try making that. Obviously it was the other way. I don't know what I was thinking. That's okay. And of course, if you guys have any ideas or any crazy functions that you might want to try, let me know, and we can totally try those now. Mirage temp, image.png. There we go. That's what I wanted to see. Look at these squiggly lines, guys. Yeah, the index parameter thing. Yeah. Okay. So here's what I want to do then. Let's go over here, make, geometrical.h. Let's use sine of inverse, and let's multiply this by, by something. Because for some reason we're still having some refraction. Or reflection, sorry about that. Total internal reflection on the inside. So I just want to try some things real quick. I'm changing the modulation of different things. There we go. The light. The light's drunkenly staggering about the lens. It's... Sorry, it's... I'm imagining each of these rays as its own, like, individual. That's just, like, it's... Like, I don't know, 2 o'clock in the morning. And they're just, like, stumbling around. It doesn't make any physical sense, but... at least it's symmetric. Okay, so let's try propagate mod now. Make that. Okay, let's see what happens with this one. It's going to take some time, but that's okay. Again, guys, if you have any cool functions you want to try, let me know. We may see what happens. Hey, that your fan? What's up? Hey. Yeah, chat. Hey, Derb10. Okay, okay, again, guys, cool functions, let me know. We're kind of working on that. We might... Okay, so here's the thing, guys. In terms of what we're doing next, because we are kind of at the end of today's simulation, in a way. We have like 30 minutes left. By the way, it's a beautiful day on this lovely island of Okinawa. I can almost see an island off the coast, which means it's pretty clear. Better than the hazy days we've been having up to this point. Hyperbolic functions. Yeah, we could try that. It's just sine h in C++, right? After this propagate sweep function, or propagate mod function, I really should call that propagate sweep. Oh, but we had... It's okay, don't worry. I misspell function all the time. Okay, And honestly, guys, because I spent most of the day working on that plotting function, do you guys want to do this again tomorrow? Because I know I wanted today to be the last day that we were doing just crazy functions and things like that. However, this is probably the most interesting thing about the simulation, the fact that we can just plug in any arbitrary function of R, and we can create some sort of crazy, how do I put this? Create some sort of crazy function. So all we're doing here is we are sending light into a lens. And the lens is weird. The lens is like some sort of weird function of R. So for example, we're going to show this one where the index parameter changes, which should be quite interesting. Actually, what's interesting about this one that we're going to be doing now, this should be quite cool. Okay, let's do mirage image.png. Let's scroll down. Oh man, it's not as cool as I was hoping for. Well, actually. One second. Okay, so we have it all light coming in. Now, one thing I have to point out here, guys. We need to modify the propagate mod function. We really do. I'm now realizing that right here. We totally need to change the propagate mod function. Because the way that the propagate mod function is currently working, it's the lens underneath, right here, is not changing at all. There's no change here. But the lens underneath should be changing. We should see it varying with some sort of, so we should be changing the index plot every time. So let me see here. What's going on with that index plot? Auto lens. Where are we generating the index plot? Draw lens? Is it in draw lens? So let's go down to draw lens. Because what we might need to do... Yeah, we might need to change that real quick. So let's think, what do we need to do? Where's our draw lens function? Okay, here. That's the only time it's called, so it must be in another castle. So let's go into opticsvisualization.h, go down to draw lens, and we should have in draw lens the ability, let me see, modifying index texture. Oh, index texture.size, draw lens. We have to redraw the lens every time. Yeah, calculus is one of those things that either you get it or you don't. In fact, a lot of people say that higher level mathematics courses are easier than the calculus classes. Okay, so index texture character. What are we doing here? Modifying index texture. Do we have multiple draw lenses? I feel like we do. No, we have the index plot functions. That's one we have multiple of. Index plot. Boom. Okay, so index plot. Let's see, what's draw lens doing? 1 second. Where's draw lens? We return index texture. So that's what we need to do. We need to create a new index texture, and then we need to change the index texture every step. That's gonna be a pain in the butt. Okay. So, guys, I know I thought this was going to be the last day that we do this. Let me know what you guys think. We need to spend one more day. So, in case you're not aware. Okay. Let's go here. So, the issue here. So, we draw the lens. We have some sort of weird refractive index pattern on the inside of the lens. Okay? But the refractive index pattern is actually changing with time. So, that means that this pattern should be changing. However, it's currently not. So, we can take another day to implement that function. And that will actually be the last day. I apologize because I know I said today was going to be the last day. Hey, Tiddly. I think we do need one more day. I apologize. I thought today was going to be the last day because everything else seemed to be up. But again, I really want that index texture changing on the inside. I really do. Because this doesn't make any sense otherwise. Like this right here just looks like it's some crazy nonsense. Okay. So, yeah. You guys okay with spending one more day on this? I again, apologize. At least on stream it shows normal. Okay. What is it on stream? Let me see. Let me go over here. It is that your fan? Oh. Fair enough. Okay, let's go over here. Pop that one over there. Yeah, I think we're gonna have to take one more day on this. I really do. But it's just a matter of changing that index texture as it goes in. Yep. Because otherwise this doesn't make any sense. So we can actually get started on that right now if we want. Okay, so what are we gonna have to do? Let's think about it. The propagate mod function currently reads in a lens. Scale. Oh, yeah, sure, let's do it. So let's go over here, VI, optics visualization dot wrong one, geometrical.h. Okay, let's see what we got here. Rank quit. We were already in geometrical.cpp. I don't know why I did that. So let's go down to the last one we wrote, which was sine of inverse there. And let's go down here. And let's just stick to the propagate function for now. And we'll do propagate mod in a bit. Okay. And what you're saying, yeah, is I assume index parameter. So let's go down here. Batman index, sigmoid function, sine inverse r index. Oh, I apparently missed a couple. Let's go down here and let's say struct for, what do we want here? I'm just gonna say index parameter divided by cosine, hyperbolic cosine of, oh, you already have that. Scale then. Of r times parameter. Okay, so we're gonna call that struct. Let's call it inverse. Cosh. Index. Ask one of my professors about him looking Raspberry Pi developers. One of my. Fair. Wait, what do you mean? Ask one of my professors about him looking up Raspberry Pi. Okay, so let's go here. There. Don't forget the semicolon. And let's do it. Double. Operator. Constant. Sphere. Of inverse. Cosine. Hyperbolic cosine. There we go. Index. Okay. Then we need to do this. Ampersand lens vector p. Oh, fair enough. Okay, so let's do this. Constant. And down here. So what we will do is the following. Double R. Double R. It's going to be equal to the same thing as it was before. Distance. Here. Now we're going to say double index. Is going to be equal to, what did we want here? 1.0 divided by hyperbolic cosine, so cosh of, what do we want? R times lens.index parameter. And we're going to add 1 at the end. Let me see, what do we have here? That your fan, one of my professors, is looking for Raspberry Pi developers for a project. Oh, hey Adam, what's up? How have you been? So that's what I meant to say. Looking for Raspberry Pi developers for a project. Oh, I see, cool. Raspberry Pi is one of those things that I wish I knew more about. Dude, Adam, did you just host me? If you did, thanks a lot. I appreciate that, man. They bought it back in the 90s, still running Windows. Wait, what? Thanks a lot, Adam. I really do appreciate that. So let's go here, index parameter, and let's see what we got. I think this one should run okay. So let's go ahead and write this, and let's just make it. Oh, of course not. I screwed something up. Geometrical.h. Dude, that's super helpful. I really appreciate it. So let's go down to, where were we? Inverse, cosh, and let's see what we got. So what did I do wrong here? I obviously forgot a semicolon. Now let's right and quit. And let's make that. Still has some problems. So let's go here, right and quit, vi geometrical.h, h, and let's see what we got. So inverse, cosh, and where are we? Here. So error, inverse was not declared in this. That's fair enough. That's because for some reason I put an O instead of this. Can't stay though. That's okay, man. I totally get it. I saw you were streaming when I came on. So have a good day. See you around. I don't know what time it is your time, but whatever time, have a good time doing your thing. Apparently the Scantron machine itself is still fine. It's just the computer that's no. I'm sorry that you're a fan. But seriously, man, I do appreciate it. Okay, so now we do index here, constant operator. Good, so let's just make this and see what happens. Dang it. Make. Okay, this one seems to be making. It's got some errors, but that's okay. Now let's see what the index texture looks like. Again, we're going to have to come back tomorrow to finish that up. There's some things to do there, but for the most part, we're getting there. So let's do Mirage, temp, scroll down a little bit, and let's see what we got here. Oh, I forgot to change it from the last time. vi geometrical.cpp, and let's go down to inverse R and change this to inverse cosine. Here we are, inverse cosh index. Write this. Now let's make that. I'll let you know when I know more. We're still looking into people and researching. Fair enough. Yeah, so whenever you know more, just come in, talk about it. Of course, I have no restrictions as to what people really talk about on chat. That did nothing. That's just a blank lens. Why is it just a blank lens? Wait. Why is it just a blank lens? Let's go into vi geometrical.h, and let's go down to inverse cosine. And let's see what happens. So 1 over cosine, hyperbolic, whatever, cosine of r times lens index parameter plus 1.0. What's the h mean? What do you mean the h? Sorry about that. Oh, hyperbolic. Yeah. So it's a bit of a different function. People don't usually have as good of a grasp on it as the standard cosine. So let's see, r times lens index parameter plus 1.0. That was totally just a blank lens. Let's sure. Make. Let's see what happens. Max index is 1. Okay, so that would mean cosine. This value is always quite large, apparently. So if I multiply this by like 1,000, let's see what happens. Make. Max index is still always 1. So no matter what, this has to be like a super small number or something is up. Let's take a look at the Mirage image. Scroll down. Yeah, it's all just 1. Let's go over here. Yeah. Let's go here to 0.0. Right and quit. vi geometrical.cpp. And let's see what we have. Inverse cosine index. I did put that one in right. So let's go into geometrical.h. Okay. Inverse cosh. Let me try it without the 1 over. Let's just try cosh. And see what's up. Right quit. Make. Okay. Max index is 1. 1 second. What is r times index parameter? What is index parameter in this case? It should be 1. Mirage temp. Scroll down. Index parameter is 1. Let's take a look at what cosh looks like. So let's go down here and let's do just very simply what everyone always does, which is Wolfram Alpha. And let me just plot hyperbolic cosine of r or something like that. So plot cosine of r. Yeah, well, okay. So we're seeing this guy there. Oh, you're right. 1 divided by. Okay, so it should be 1.0, And then it should drop down by 1.0 here. Index parameter should be 1, so you're right, we should be seeing this. Then we're adding 1. Huh. Okay, I have no idea what's happening with this guy. So let's go into geometrical.h. Let's go down to... what do I want to do? Let's go down to what we had before. So inverse cosh. And what do we have? Double R distance, lens.origin, P, lens.radius. Double index cosine of R times lens.parameter plus 1. Not sure. 1 over is what I meant. 1.0 divided by cosine. Okay, R times lens index parameter. Wait 1 second. Lens.radius. Lens distance. I think I'm doing something wrong here. Let's divide this. No, it is divided by. Dang. Holy crap, this whole time. Oh man, that's embarrassing. I've done this before too. Oh man, return index. Right and quit. Make that. Okay, now let's see what happens. Give it a second to do its thing. Max index is 2. It's clearly doing something. Okay, so now let's do Mirage. Scroll down. Okay, so this one didn't really do so much. However, let's look at it one more time. Geometrical.h down to inverse cosh. And let's see what we have here. So it's 1.0 divided by R times lens index parameter. I want to multiply this whole guy by an arbitrary factor on the inside. So let's change the index parameter up here to be something else. So where's the index parameter? Where do we define our lens? Lens here, make sphere 1.0. Let's change this to like 5. Okay, let's see what happens here. This, I think, should cause some variation on the inside of the lens, which should make it a little bit more interesting. So let's do Mirage Temp, scroll down. There we go. So we have some variation, but ultimately... Wait, it does? Let me see what happens. So let's change the index parameter again, back to 1.0. And let's make. Give it a second to draw. In fact, let's just do a sweep. So let's do what we did before. So let's go to propagate. And let's go here. And let's do a sweep here. And let's make that. Okay, give it a second. Oh, this is going to take a while, isn't it? The previous one seemed to. Well, I guess while it's doing this calculation, we can... Oh, I guess it's drawing a frame every time, isn't it? We'll just give it a second to run. And while it's running, let's see. This is going to take some time, though. In the meantime, how is everyone? I hope you guys are doing fantastically. And if you have any questions, comments, concerns about what I'm doing, just feel free to post it in chat. We've got a few minutes left in the stream. Unfortunately, Adam's host came like kind of at the end of my stream, so I was going to be ending quite soon. So if you guys have an idea of who you want me to host, that is people from Adam's stream too, since you came here, come into my chat, let me know who it is, and I will host that person at the end of the stream. So just throwing that your way. I typically end the stream at 7 o'clock a.m. Japanese Standard Time, which is in like 6 minutes, but I can hang out for a little bit longer today. Not that much longer though, because I got to get to work and do a whole bunch of other things. So, throwing that your way. If you guys have someone you want me to host, let me know, because I'll totally do that today. Okay, so this guy's still taking a while to run, and I've got a feeling that maybe I shouldn't have let it run for so long. So, let's see. It's probably going to take another minute, isn't it? You should host Adam. Maybe that will force him to stream. Sure. I mean, Adam's a pretty good streamer. Used to be, I would host his stream almost at the end of every one of my streams because he was one of the few streamers that still does, you know, a good bit of programming on Twitch. And that's okay. Well, I'm almost done here, Gustorn. Come on, give me a minute. Yeah, maybe I should have just done normal propagate. But we're almost done. You know? We're more than halfway done. So, give it some time. We'll get there. But yeah. Guy on a motorbike just went by. Anyway, so it's actually kind of interesting. I like the cut of your jib. I don't know what that means, but I'll take it as a compliment. So one thing I want to point out is the new students are actually coming to OIST pretty soon, and I'm pretty excited to see them, but I have no time to hang out with any of them. So I know a couple of them beforehand, like some guy works on like 7 component BEC stuff, and I know him quite well, but well, okay, I've seen him a few times around. But all the new students, I don't know them at all, and it's kind of frustrating, I think, because, you know, I want to know all the new students. Like, I want to be very active, but I don't know. It's kind of hard. But I'm pretty excited to see them come in. Should be good. But if iProgram and seeing it actually focus with a spherical lens, that'd be pretty cool. Yeah, sorry about making you wait so long, Gustorn. Took about 3 minutes to get that simulation run. But we'll see what it looks like. Again, we do need to modify Propagate Mod. So I do think, somewhat unfortunately, we need one more day to do this. I thought today was going to be the last day we were going to be working on this simulation, but we need one more day. Definitely need one more day. Because we need to modify the interior lens index as it changes with time. Give it a second to wrap it all up into some images, and then we should be good to go. Actually, why does it take so long as it goes along? Let me think. How are we generating these guys? Let's go down to Propagate Mod. And let's see. Ray Array Index. Let's see. Let's take a look over here. Last Mirage. Okay. So now we have standard Propagate looks like this. Okay. And as we go through. Okay. So we do see a clear focusing here of everything going in. Yeah, I'm not sure. I actually, maybe it's just a hyperbolic cosine taking so long to run. But you're right, we do clearly see a focusing, but the focusing isn't so much difference. Sakine, I'm using Arch Linux with, let me think, the OpenBox Windows Manager. But it's always focusing inside of the lens. No matter what, I don't think we can get it outside of the lens. So this is like having a refractive index of like 10 or something like that. Interesting. Let me try one more thing. So let's go up to the top. Let's go down to the propagate mod function. And from now on, Gustron's right. We should probably just stick to propagate for stream. And then I'll do the propagate mod stuff on my own time. But I'll be finishing up writing propagate mod tomorrow. Okay, so if you guys have any other functions you want to try, let me know. I would like to try one more thing, which is, let me think. Going into optics visualization, or geometrical optics.cbb, or H, sorry about that, geometrical.h. Going down to the bottom here, let's go down to inverse cosine, which is the one that we just added in. Okay, we have this guy here. Where is it? Inverse R index. Okay, so this index is kind of weird. And I feel like we do need to do another sweep through to really make sure it's working the way we want it to work. But let me try something real quick. So I want to change this to, what did I call it? Sine inverse R index. Inverse R index. Okay, and let's change this so instead of adding 2, we add 1. Right quit. And let's make that. Give it a second to do its thing. It won't take nearly as long as the last one, because it just won't take nearly as long as the last one. And then we will go from there. Okay, so let's do Mirage. Scroll down. Okay, here's the light going through. Yeah, see, that's what I'm fearing, or what I expected. The light here, no matter what, it's always being... Yeah, it'll always reflect at some point. Okay, let's try it again. Adding 2. Let's see, where are we? Geometrical.h. Sine inverse R. So adding 2, though, I think it gets all the way through. Let me see what happens if we add 3. It's probably really stupid. Let's make it. Max index is 3.5. That's fair enough. It's going to be 3 plus 0.5. So we're basically varying from an index of 2.5 to 3.5 with some sort of sinusoidal oscillation. Okay, let's take a look at that. Mirage temp. Oh, that's not nearly as interesting as I was hoping for. But But see, this is the thing that's kind of bugging me, you know? Like even here, we are seeing, oh, these aren't reflections, are they? No, this is actually really cool. So this is not reflecting on the inside of the lens at all. It's refracting into weird positions. Huh. Okay, that's fine. That's fine. I just had to be sure. So let's go back, change that to 3 like it was before. Again, going to sine inverse index of R or something like that. There we go. Change it again to 2. Yeah, that's fair enough. Okay. Right quit. Make that. It should always reflect with +1. Wait, what do you mean it should always reflect? Oh, yeah. So with +1, there will always be a point where the index is under 1. You're right. Let's go to Mirage. Okay, so here, yeah, these aren't reflecting either. Okay, so the idea here is that we have like all these rays just kind of like drunkenly staggering in and coming out. But this guy right here is the most important one. The fact that he turns almost completely around without any reflection at all is incredibly cool. Now, that's not the only lens that does that, right? There are a whole bunch of other crazy lens parameters that will do this. But I still think that's pretty cool. Okay. So, let me think. It's currently 7 o'clock in the morning. This is typically the time I end my streams. I have, of course, I am live from 5 to 7 o'clock a.m. Japanese Standard Time every single day. Well, almost every day. Some days I take like weekends off or something like that. But for the most part, you can log in at 5 o'clock in the morning, find me here, or whatever time it happens to be your time. So that's going to be like, let me think. What time would that be? That would be whatever time it is now, minus 2 hours your time. We have some stuff left to do. Mainly, I want to modify the interior index here for the propagate mod function so that we can see the index as it's changing with time, which is going to be super cool. I'm really looking forward to that. And then I'll probably take the weekend off to edit a YouTube video on this kind of stuff, and we'll be back on Monday after that to work on the next simulation, which, by the way, I don't know what I want to do. Kind of up to you guys. I have a couple of ideas. Let me think. The first of which happens to be, let me think. Octrees, if you guys have ever heard of them, it's a way to go through and find the position of all these different particles, so to speak, on a 3-dimensional grid, hence the name oct, but could be 2-dimensional, which would be quad trees, I guess. And it's a way to find all the particles there. It's really useful for fluid simulations. Then let me think. The other thing I wanted to try was just kind of going through and doing a very simple FFT from scratch, just because I've never actually done an FFT from scratch. I always use standard FFT libraries like FFTW or cuFFT or something like that. And I think that'd be a lot of fun. The next thing I'm trying to learn right now is mapping, like 2-dimensional to 3-dimensional objects, doing some sort of weird conformal mapping, but I'm not sure about that. Cosine, right, is just a 90-degree shift from sine, so it should be pretty much the same. Right? I mean, it's just a phase difference. I would imagine it'd be the same. Anyway, guys, so let me know what you guys are thinking. If you want me to do any of those simulations, or you have a simulation you want me to try, let me know, because I'll totally, look into that and try it next time. Now, what is next? Okay, so I think, honestly, that's going to be it for today. Again, let me know if you want me to host somebody. Actually, we can just very quickly go on programming, because I know you guys probably, let's see, let's go here. Refresh programming. It's been a while. I apparently was watching that guy the whole time. And let me see. What do we have here? It was muted. Let's pause his stream. And if you guys see someone you want to work with, let me know. Otherwise, I'll just go ahead and end the stream now. So I'll give you guys another minute or two to think about anyone you might want to host, and then we'll just kind of call the stream there. For now, I'm going to go ahead and commit this to GitHub, and while I'm doing that, let me know if there is anyone. So let's go ahead and clear here, and let's go ahead and clear here. Now let's do a git status dot, and what do we have here? Geometrical.cpp, geometrical.h. Let's do git commit geometrical.cpp and geometrical.h. I don't think anything else needs to be updated. That should be okay. Thanks, Gustorn. And we're going to say -m, adding the ability to plot functions of R. Okay, let's go ahead and do git push origin master, and it's now going to be available online, so just 1 second. There we go. Okay, give it a second to do its thing. Everything seems good. And of course you can find this. Here's my channel. Scroll down a little bit to info. Scroll down a little bit past that. And go to github.com right here. And you can find all my stuff here. So it's going to be in the Simuleos directory. And then just go to, where is it? Geometrical Optics. And geometrical.cpp was the file that we changed. But you can of course see all the changes that we made today just by clicking the latest commit up here. 1 second. Is this a tab? Holy crap. Why is it a tab? One second, I have to make kind of an important change here. Somehow or another, everything turned into tabs. Not sure why. Let me change that. Let's go into VI geometrical.cpp. Let's see, which file is this? This is in geometrical.cpp. And let me just check to make sure. Let's check to make sure. Let's go to 32. Oh my gosh, that's totally a tab. Dagnabbit. So let's go Vim. Thanks, Tablot. Okay, so let's go geometrical.cpp. And let's change everything. So we're going to do this. S. We're going to do tab. Okay. Right, quit. Git. Did something happen? Oh, yeah. I didn't even notice he changed it. So let's do git diff, and let's do geometrical.cpp. Okay, so this changed everything back to the way it should be. And let me just make sure there were no additional weird tab changes to geometrical.h. Doesn't seem like there were. No, so I think that's fine. It can, actually, but unfortunately it doesn't work with tabs. It works with everything else but tabs. So, sorry. Obviously you can't do search and replace with VI, but I opened up Vim for this. So let's do it. Let's do git commit geometrical.cpp, and then we're gonna say message changed all tabs back to spaces. Now I'm not sure why that happened in the first place, but let's do git push origin master. And now we're done for today, guys. So that change should have fixed everything back to the way it should be. So let's go here. And let's, I guess, what am I doing? Let's go back here a second. Go to ability to change. Oh, wait. I have to refresh the page. Change all tabs back to, oh, I misspelled back. Okay, but that's fine. Tabs and if CR changed. Let me think. Wait, LFCR changed. I'm not sure what you mean by that, but that's okay. So I think everything's back to the way it was. There might be something here and there. Again, guys, if you have additional functions that you want me to try, just send me a pull request, send me a message on Twitch, something like that. Tomorrow is officially going to be the last day of Geometrical Optics. We'll take the weekend off while I work on the next simulation. If you have ideas for the next simulation, give me your notes or send me some messages there. Line feed, carriage, return. Well, I've got to go. See you guys next time. Yeah, see you guys tomorrow. I'm also heading off. I didn't see anyone you wanted me to host, so I'm just going to go ahead and end the stream here. But again, let me know right now if you wanted me to host anyone. Outside of that, have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, where we finish up the propagate mod function, and everything else should be absolutely fine. So thanks again, guys, for coming in, and I will see you next time. Bye, guys.